Formerly, his last company, I think, was acquired by Perkin-Elmer, where he eventually became the global head of R&D for Perkin-Elmer, and now formed Orig3n just recently. So he's going to tell us a little bit more about what's going on in the back, which is good, so we'll know why we're drawing your blood, and I'll turn it over to Robin. Thanks.
Well, thank you very much for having us here, and I also want to have a chance to walk through what we're doing and share with you why we think regenerative medicine and Orig3n is the future of medicine. But before we begin, I did want to say thank you to Harrison Harris Group. We are honored to be part of the family here, and these things startups and organizations never come easily. So we always are very thankful of everything we're able to do. So I'll begin with a little bit of a story about how we think about regenerative medicine where it is today. We are all doing this because we think we are on the cusp of a massive industrial revolution. We all know that in the next 9 to 10 years, the idea about what you do when you're sick is going to be radically different than it is today. We believe that regenerative medicine is one of the pillars of that change that's going to be happening. And we like to make the analogy of the internet of 1993. If you could think back to what you were doing in 1993, some of you, I'm old enough to actually, be in this mode. Some of our staff is very young, so they're like 1993. They just don't get it. But if we took a time machine and I dropped an iPhone in somebody's lap in 1993, they would think that's alien technology that came out of nowhere. If you think what's going to happen in 10 years around regenerative medicine, the idea that you're going to get sick, the idea that you can't repair damaged hearts, the idea that you have a broken spine, those things are actually going to go away. And this is happening today. And that's one of the things that I want to really make sure that everybody here is aware of, that this message that regenerative medicine is actually taking place today. It's just not happening in the United States. And that's one of the reasons why Orig3n's formed. One of our missions here is to really drive the education and build some core capabilities that even the organizations in Japan and overseas are lacking. And we want to be ready for this revolution when it begins. Oh, okay. Right now in Japan, there are roughly around 600 clinical trials going on in regenerative medicine. And these trials range all the way from repairing cardiac damage to repairing spinal injury to repairing macular degeneration in the eye. There is an entirely new mechanism for getting through protocols for clinical trials in Japan. If you get 20 people to be in a cohort and you prove safety, you get 7 years of conditional approval. Now that's mind-blowing. It's actually faster to get regenerative medicine therapy into the market in Japan than it is a small molecule trial. And they're doing things like building hotels and getting ready for the onslaught of individuals that are coming over, that will be coming over for regenerative therapies. So what are we doing to actually help advance the cause in the United States and also in regenerative medicine? We're creating the assets necessary to actually implement some of these regenerative medicine therapies. When you go to these conferences and you hear organizations talk about what they're doing around regenerative medicine, the first thing they say is, we need a bank of human tissues to actually use to actually make these things happen. Orig3n is creating that bank of human tissues. We have a component called Life Capsule, and we are actually crowdsourcing blood samples, and getting full consents for people to actually donate a little bit of themselves to the future of medicine. We're going to see 8.5 million people in the United States this year, and when we talk about touching people, we actually physically touch them, and then we poke a needle in their arm and get a little bit of blood. You can actually participate by going in the back. We have a couple phlebotomists, and we do this every day. We do this every day across the nation by the thousands. So it's been a really interesting road for us to see how that gets built up. From that, we generate two things. We have a product called Life Profiles, and you'll see those in the back. They're small genetic tests that actually let us tell people a little bit about themselves in a non-threatening way. You'll see we have a product called Fit Code that does fitness assessments, Aura that does skin assessments, and one called Superhero, because we also get donations at Comic-Cons, and this is a really nice way for people to get exposed to how superhero your genes are. We have language learning, strong bones, and fast twitch muscles, so if you're smart, fast, or strong. And that's been a really good way for us to engage with consumers, and there's a conversion rate that we can measure. But I'll talk a little bit about why we're gathering that blood. So, it's kind of abstract. You're getting blood from people. What do you do with that? we actually have a technology that allows us to take blood from individuals. So we could take any one of your adult blood cells, and we can reprogram it back to a 3-day-old state. And this is the foundation of what's going on in regenerative medicine. So with that blood, we take it back to a 3-day-old state, and then that blood cell that's converted is identical to a stem cell. And this bypasses all the ethical issues around embryonic stem cells. This was invented in Japan in 2006 by Shinya Yamanaka. He won the Nobel Prize for this in 2012. So just in a few short years, he won a Nobel Prize on this technology. It's transformative. From there, we take those induced pluripotent stem cells, iPS cells, and we can actually differentiate those into various human tissues. So we can generate cardiac cells, we can generate neurons, we can generate hepatocytes, and the list goes on and on. Those 3 types are the ones we work on today. And it's really important for us to get human diversity in these cells because we could do a lot with that. So these cellular models that we build up can replicate diseases. They can model diseases. We can actually test drug efficacy against cardiac cells. And I'll talk a little bit about what Life Capsule is actually doing around the country. So these are a few photos I'll go through, and then we'll go into a little bit more detail around the technology. But you can see here, people line up at events. This is amazing to us. We've been out there, for the past year and a half, asking for people to participate in the future of medicine. And if you can all remember, about a year and a half ago, there was an ice bucket challenge where people are pouring ice buckets on their head because they just wanted to do anything to help. And this way, their actual sample is becoming part of this library that's being used for research and development. And you can see them lining up here. This is Beta Breakers. Somebody's wearing butterfly wings. They're sitting down donating. People take selfies and photographs of their arm with the Band-Aids on these things. We're everywhere. If you go and notice, we're at parks. We're outside of stadiums. We're by the Space Needle here. Young, old, people dressed up. We go to military events. We actually get entire cohorts, so families with afflicted children, their parents are consenting to get their sample, the parents that may or may not have the disease. So it's really fascinating for us to get entire cohorts of individuals into the bank. And you can see the list goes on and on. We have a little bit of a video here that I'll show you a little bit more about what we're doing.
This is a heart cell, a liver cell, a neuron. We made them, all of them, from half a teaspoon of donated blood, from someone just like you. These cells are being used to test medical therapies for people with genetic diseases. This is a revolution in biotechnology. Join us.
So it's really fascinating to see how people react to the message. So we're getting donations from across the country, as I said. And, when we say we make them, we actually do make these cells. And it's fascinating in our laboratory. If we were to take an individual's blood sample and make cardiomyocytes out of those blood samples, they actually start beating. And in that video, you saw the cells pulsing. They actually start beating in a Petri dish. And it's the coolest thing to see. The heartbeat that's actually happening in that Petri dish is exactly like the heartbeat of the donor. So if you had a genetically inherited cardiac condition like long QT syndrome or an arrhythmia, we could actually look at and measure that arrhythmia in the dish. The other cool thing we could do with that sample in the dish is we can actually add drugs to it, we can modulate it, and we can see what works for that individual's heart cells without actually having to do that to a person. And it's mind-blowing. It's awesome. We have incubators full of heart cells in our lab, and you can go and pull them out and look at them and watch them kind of beat away. Neurons also have action potentials that you can measure, and you can see those things moving around as well. It's absolutely amazing. Oops, sorry about that. I'll skip through. Not only are we collecting samples from the general population, but we also work very closely with foundations. And this is very important because we have healthy, normal cohorts, and as we're finding when we interact with tens of thousands of individuals, nobody's healthy or normal. You're just not sick right now. And we work with foundations where people with various serious diseases that are genetically inherited help us get these really great snapshots of these diseases. And that's enabled us to actually build up to some of the largest disease cohort databases anywhere on the planet. And this number is actually way outdated at this point. We're way over multi-thousands of disease samples in particular, and we have probably the Parkinson's cohort that's the largest on the planet at this point in time. It's pretty mind-blowing. So The other thing that we're doing is, as a not a traditional type of biotechnology company, we're partnering with various organizations that give us access to more and more patients and more samples. So one of the things we're doing, and we've launched just recently, is a pro sports partnership with the San Francisco 49ers. And this is, this is really wild. We were just over there with these guys last week at the stadium. We're doing a couple things. We're actually taking blood at the stadium at the football games. And we have access to the 68,000 fans that show up for these games, every weekend. They're also giving us signage on the ribbons that go around in the game. So 30 seconds at a time, we can distract the other team by, animating some, blood going around the screen, and we can make some calls to action. It's really great. And the other thing we're doing with them is they have 5.7 million fans just in the 75-mile area around San Francisco. And they're launching with us, that fan base is called the 49ers Faithful. And they're launching with us a program called Orig3n's Faithful DNA, where people that donate get enrolled with opportunities to win tickets to games, meet the players, those kinds of things. So it's a way for us to increase the scale of our outreach, which is really amazing. And here's just a quick picture of what that blood collection infrastructure looks like. They're actually donating over to us some infrastructure to take blood. So we'll be there, as fans roll in from the meetings. So we have 3 parts of our business. As I said, our future isn't just collecting the blood, it's what do we do with that blood. We have Life Capsule, which is this personalized drug efficacy and tox screening bank that we're building for consumers. We have Life Profiles, which are these genetic tests. And then, as we're moving through the seasons of our business, building the bank, organizing the bank, and then profiling the bank, we'll be getting into actually doing things with those cells, like modeling diseases, and then furthering the cause for regenerative medicine. I'll flip through a couple of these really quickly, but we have some products in the back you guys can check out. There's the superhero product. It's really lively. And one of the more recent items we've had is a drug discovery alliance with Sharp Edge Labs, where they're using our patient-derived Parkinson samples to help advance the cause for Parkinson's disease. And it's a way that the first time ever that anybody's been able to use human models real early in the drug discovery process and model that. We have a good team. Myself and Kate are here. Marcy Glicksman's our science person in our lab. She's the one responsible for helping to drive some of this effort. Jish Mukherjee is from Apple. He ran marketing for iPhone and iPad, so you can see a lot of where our DNA comes from marketing directly to consumers. And then finally, we strongly believe that if we can actually create this asset, we're going to be in a really interesting, unique position in this market for regenerative medicine, and we can really drive that. We have a lot of key partners here. We have some great investors in the organization and some great helpers here supporting us. And I think the next phase for our company as we're doing these updates will be what are we going to do around disease modeling, around cardiac conditions, and we're happy to talk to all of you about that. And we also want to make a call to action here. So go in the back, give a teaspoon of blood, it takes 90 seconds, and you'll actually see what happens with these types of organizations and these types of meetings that we do around the country every day. So that's it. Any questions?
I'll ask a question. Can you just talk a little bit more about, we were just talking the other weekend, but I know it's happening in Japan, but where they're using these stem cells and what they're seeing in disease states.
Yeah, so we've seen some really awesome regenerative medicine things that are happening. One is this group in Osaka University, Dr. Sawa's group. He runs this cardiac center, and they're growing cardiac sheets. They look like crepes. It's about as big as a crepe, and it's pulsing. It's really gross to see. But they're actually putting these things on damaged mammalian hearts, and it's amazing. These cells just melt right in, and they just continue to pulse. And they measure these hearts over the next 3 months, and you see the actual heart decrease in size and repair itself. So it's absolutely mind-blowing. He's been nominated for the Nobel Prize just recently, so that's just recent news that's happened. The other is spinal injury. So we also were able to see a video where they had a monkey with a broken spine, and they were putting human iPS cells into the spine, and within 3 weeks, that monkey's jumping around. And so we're watching these videos, and we're looking at this stuff, going, "Oh my God, this is some nutty stuff that you wouldn't, you'd think it's completely science fiction." But the the promise of stem cell technology, but these stem cells are a little bit different. These are not adult stem cells, which are also partially differentiating your body. It's not like doing apheresis where you have to take some cells out and try to make it stick in a certain location. These are naive stem cells that you can actually turn into differentiated tissues that are exactly matched to that individual and then reimplanted in for repair. So I think it's a good question, and there's a lot of activity going on there. Any other questions?
You must have a lot of interesting legal issues about what happens with the application and use of these stem cells to parties that are unknown to the donors.
Actually, if you're going in the back, you'll see our digital consent. So we actually consent the cells as we're getting the donation, and we ask people to sign a waiver that waives all of their future rights to those cells. And it's pretty clearly delineated there. It's very important for us to do that. Go ahead.
Other side.
Oh, that's a really good question. So right now, the regenerative therapies that are going on, they're actually a person's donating either a skin fibroblast or blood, having that converted to iPS, and then put back in that individual. So this is all N of one. It's like my stuff coming back to me right now. So that's the state of the marketplace right now. There's a lot of programs going on where they're talking about doing, banks of tissues that are matched to humans, but that hasn't come around yet. I think it will, and hopefully will be there too. There's a lot of issues with that, and there's a lot of time necessary to kind of develop that. But right now, it's mostly an individual cells being converted and then given back to that individual. So it's you're only the one to blame when something goes wrong on that. Yep. Thank you, guys. Yep.